Section 5.3, Applying Newton's Laws. So this video is primarily going to focus on the first learning objective, identifying Newton's third law of motion and third law force pairs. Then the rest of this section is looking at some examples. So for an object that moves vertically on a horizontal or an inclined plane, how we can apply Newton's second law to a free body diagram of the object. And even how, by the end of this chapter, hopefully you'll be able to apply to an arrangement where a system of several objects is moving rigidly together. So drawing a free body diagram and applying Newton's second law for the individual objects, as well as for the system taken as a composite object, right? Looking at Newton's second law on a system of objects moving together. But first we're going to start with Newton's third law. So Newton's third law is based on the idea that objects will interact whenever they push and pull on one another. So he says when two bodies interact, the forces of the bodies from each other are always equal in magnitude and opposite in direction. This is known more colloquially as every action has an equal and opposite reaction. So every force is the action has an equal and opposite reaction. This I like to demonstrate if I hit the wall. Right? If I hit the wall, it turns out it hits me back. I feel a force. If it didn't push back on me, then my hand would just pass right through the wall. But instead, it pushes back on me in the opposite direction of my push. Now, how much does it push back on me? With an equal magnitude, even though it's opposite direction. So if I lightly tap on the wall, then it lightly taps back. It's all very nice, very pleasant, like a golf clap. But what if I instead smack the wall really hard? Then it smacks back. That wasn't a very nice wall. But it was in response to what I did. So I guess I'm at fault there. So that demonstrates Newton's third law of motion. We can write this as a scalar or a vector relation, right? Here we say the force of B from C is equal in magnitude to the force on C from B. In the vector form, if we add the vector symbols, we'd have a negative sign to show that it's the opposite direction, because negative signs are just telling us about the direction. So we'd call these two forces a third law force pair, right? The force of me hitting the wall and the force of the wall hitting my hand. Anytime two objects interact, there's a third law force pair. So this is useful when you're solving problems because you can identify, hey, if an object is pushing on someone, then that person is also pushing on the object. It goes both ways. So let's look at this in an example. So we have a cantaloupe resting on the table on the earth. This is a giant cantaloupe and a giant table, but it works better in the picture that way. So there's a couple of third law force pairs that can be here, right? One, we could consider the cantaloupe and the table. So the cantaloupe is pulled toward the center of the earth down, and so that's pushing on the table, and so the table is going to push back on the cantaloupe in the upward direction. That's a third law force pair, equal and opposite forces, equal magnitude, opposite direction forces. We also can look at the cantaloupe and the earth itself. But the cantaloupe feels a force pull, gravitational attraction to the center of the earth. Turns out the earth also feels an attractive force to the cantaloupe. It's a tiny force relative to the mass of the earth, so there's no real change in the earth's acceleration, but there is actually a third law force pair there, where they have equal magnitude and opposite directions. So that's really nifty. All right, so this pulls us through Newton's third law of motion. And in the next sections, we'll look at some specific examples where we can apply all of these laws of motion into solving some problems.